There are different raw materials used in making iron. In the manufacturing industry today, iron and steel are the most common materials used for large varieties of applications. Iron is a lustrous, ductile, malleable, silver-gray metal, known to exist in four distinct crystalline forms. It is Group 8 of the periodic table. Today, 90% of all metals are iron, mostly used to manufacture steel. They are often used in civil engineering for reinforced concrete, girders, etc. Well, in this video we'll explore what iron is, its applications, types, properties, raw materials used in making it, and how to make them. A quick reminder to subscribe, like and share this video. What is iron? Iron is a chemical element with the atomic number 26 and the symbol Fe derived from the Latin ferrum, denoting iron. Iron is a member of Group 8 and the first transition series of the periodic table. It makes up the majority of the planet's outer and inner core and is, by mass, the most common element on Earth. It is mostly deposited by meteorites in its metallic condition, making it the fourth most prevalent element in the crust of the Earth. Kilns or furnaces that may reach 1500 degrees Celsius to 730 degrees Fahrenheit, or around 500 degrees Celsius 932 degrees Fahrenheit greater than what is needed to smelt copper, are necessary to extract usable metal from iron ores. Iron is considered to be the 10th largest element in the universe and the metal with the greatest abundance on Earth. It is believed that a significant portion of the iron in the Earth contributes to its magnetic field. Iron is also the most abundant element in the Earth, with amounts ranging from high at the inner core to about 5% in the outer crust. It is possible that the Earth's inner core is made up of a single iron crystal, though it is more likely to be a mixture of iron and nickel. A metal that is removed from its magnetic field is iron. Iron is a metal that comes from iron ore, very rarely found in the free state. Applications. The below explanation are the applications of iron. Steel is produced with iron, and it's used in civil engineering to make items like girders and reinforced concrete. Alloy steels, which combine iron with nickel, chromium, vanadium, tungsten, and manganese as additives, are like carbon steels. These products are used in the production of rifle barrels, bicycle chains, electric pylons, bridges, and cutting tools. 3 to 5% of cast iron is carbon. Pumps, valves, and pipelines are made with it. The Haber process uses iron catalysts to create ammonia. This metal, as well as its alloys and compounds, can be used to make magnets. Iron is widely used for the production of appliances and utensils, from knives and cutlery to plates and pots. They are also used in making electric motors that can power homes, appliances, and industries. Take a moment to study everything around you. You'll notice 80 to 90% are made of iron. Properties of iron. Earth's inner core is believed to be an iron-nickel alloy with epsilon structure, with 4 allotropes known: alpha, gamma, delta, and epsilon. The melting and boiling points of iron are lower than earlier 3D elements but higher than manganese due to its half-filled 3D subshell. Magnetic properties of iron include the spontaneous partitioning of atoms into magnetic domains, making objects permanent magnets. Iron has 4 stable isotopes: 54 Fe 5.845% of natural iron, 56 Fe 91.754%, 57 Fe 2.119%, and 58 Fe 0.282%, and 24 artificial isotopes created. Advances in mass spectrometry have allowed for the detection and quantification of variations in stable isotope ratios of iron, providing insight into the origin and early history of the solar system. Iron is the most abundant element in the core of red giants, iron meteorites, and dense metal cores of planets like Earth. Different types of iron metals. The different types of iron available today are cast iron, wrought iron, white iron, malleable iron, gray iron, and ductile iron. 1. Cast iron. Smelting iron with carbon, silicon, and other metal alloys produces cast iron. Cast iron is heated to a molten state and then poured into various molds and castings to make a variety of items, including frying pans. Cast iron comes in a variety of forms, including gray, white, ductile, and malleable iron, which are produced by different methods of processing and heating. 2. Wrought iron. Wrought iron is in various forms, including gray, white, ductile, and malleable iron, which are produced by different processing and heating methods. One of the first iron metals that blacksmiths produced was wrought iron. Iron is heated in a furnace to the appropriate temperature in order to make it. Afterwards, the blacksmith uses a hammer to mold the iron into different forms based on the final result. Reheating wrought iron allows for more bending, shaping, and hammering. Wrought iron, in contrast to other forms of iron, is mostly composed of pure iron with very little carbon and other impurities. Wrought iron thus becomes incredibly strong. It is ideal for wrought iron fences, gates, and doors because of its strength. In addition, wrought iron was a common building material used for support beams prior to the invention of steel. These days, doors, gates, railings, and decorative pieces are the primary uses for wrought iron. 3. Malleable iron. White iron is heated and cooled repeatedly to create malleable iron. Graphite molecules are released into the iron carbide by heating and cooling the iron further. Products made of malleable iron may bend without breaking and have decent amount tensile strength. This iron may be used for a variety of purposes, including as electrical fittings, washers, pipe fittings, tools, farm equipment, and machine parts. 4. Gray iron. Another type of cast iron is gray iron. The shredded iron contains graphite, which gives it its color. This iron metal has anti-corrosive and wear-resistant properties. Sometimes, gray iron is used outside in place of wrought iron. 5. Ductile iron. Ductile iron is another type of cast iron. Magnesium is added to the cast iron alloy to create it. Instead of breaking like gray iron does, the addition of magnesium initiates a chemical process that causes the graphite to become spherical. By varying the amount of magnesium added and the amount of heat used during the production procedures, various kinds of ductile iron may be produced. 6. White iron. White iron is another kind of cast iron. The graphite is taken out of the cast iron to make it. The white color of white iron results from the removal of graphite. White iron is highly malleable while having a respectable level of wear resistance. Because of this, it is usual practice to use cast iron below the white iron, leaving the white iron just on the outside of the final product. This can be accomplished by allowing the inside of the iron to cool considerably more slowly and solidify as cast iron, while the external surface of the iron is quickly cooled to remove the graphite. Raw materials used in making iron. The basic raw materials for making iron are iron ore, coke, limestone, and sinter. 1. Iron ore. Iron ore is one of the basic among other raw materials used in the production of iron. It is described as any mineral substance that contains enough iron which makes its smelting a viable proposition, i.e. an iron content of less than 20%. Ores vary considerably in form and composition from one source to another. Some ores are naturally found as very hard rock, some as granular masses, and some as loose earthy materials with color variations from black to brick red. Iron is found as a chemical compound, usually an oxide within the ore. These ores are generally smelted containing iron oxide materials like magnetite, hematite, and limonite. Magnetite ores are the richest known, with around 65% of iron. It is a ferrosulfuric oxide Fe3O4. That is, black, dense, and strongly magnetic. 2. Coke. Coke plays 3 important roles in the black furnace during the production of iron. It serves as fuel to provide heat for smelting, as a rich source of carbon monoxide gas into iron, and as non-clogging support for the burden the charge in the blast furnace. Its porosity aids the free passage of the gas air through the furnace. It is made by roasting specially selected coking coal in large sealed ovens. Volatile substances produced whilst the gases released are clean and used as fuel in other parts of the plant. Coke is one of the raw materials used in iron making as a substance made by heating coal until it becomes almost pure carbon. 3. Limestone. Limestone serves as a fluxing agent with the extraneous materials gang associated with the ore. It combines with these materials clay, etc., and makes them more readily fusible, forming a liquid slag that separates from the iron. 4. Sinter. Sinter is made of laser-grade, finely divided iron ore that is roasted with coke and lime and enables it to remove a large number of impurities in the ore. Some other metals such as chromium, nickel, manganese, molybdenum, tungsten, etc., are sometimes mixed with iron for the production of various steel. How to make iron. Pig iron, a product of the blast furnace process, was created by skilled workers in the charging house. These workers ensured the correct amounts of ingredients were added to the blast furnaces, which were large ovens used to cook the iron mixture. The ingredients for pig iron included limestone, ironstone, coke, and air. The iron ore was roasted in calcining kilns to remove impurities, and the air was blown into the blast furnace by powerful steam engines. Limestone was added to act as a flux, combining with the impurities in the iron ore. The mixture was heated for the required period and slag was removed from the blast furnaces. The molten iron was then allowed to flow into prepared sand beds called pig beds, where it was set. Pig iron was then taken to refineries, forges, and rolling mills. To blast refineries that were used to burn out impurities before puddling. After refining, the metal was cooled in a cistern or water trough. The forge initially used helve hammers, chaferees, and fineries for refining iron. However, this method became unprofitable, leading to the installation of a steam engine, puddling furnaces, and to new hammers. In 1810, the engines provided power to work 3 shingling hammers and 1 drawing hammer. The forge had 10 puddling furnaces, 2 balling furnaces, and 1 chaferee. Iron was brought to the forge from refineries, reworked in puddling furnaces, reheated in balling furnaces, hammered, and drawn for rolling mills. The forge used wheelbarrows, carriages, and 14 water boxes for cooling working tools. If you find this video interesting, don't forget subscribe, like and share this video.